Today I'm going to talk about what we do, what my group does at Oak Ridge, which is we monitor the supercomputers there. Just to give you all some background on me, if you don't know me, I worked at ConocoPhillips for 10 years. I was doing program optimization primarily, worked with the system administrators a lot. I wrote an application that was called Cluster View that kind of gave us a bird's eye view of their cluster there. And then, as I moved more into program optimization, I used a lot of the data that I'm now producing. So I'm trying to produce the data that I'd want if I were doing things. So that's what I do in my current role. So we're going to talk about telemetry data in general. We're going to talk about collecting it, using it, and some of the future plans of our group. So telemetry data. Are you listening? We all have clusters, right, that are producing a lot of data. At Oak Ridge, we're producing and consuming over 25 megabytes per second of telemetry data. Right, so this includes water temperatures, water pressures, CPU powers and temperatures, GPUs, chassis, power and temperatures, node statuses, job to node maps, right? Y'all are all familiar with this data, you use it, but how often are we listening to it beforehand versus just kind of trying to dig into it at the time of an issue when someone calls you and you're like, oh, okay, I'm gonna figure this stuff out. So our goal is to help everybody in our organization be more proactive when they have issues, right? So Orion is our file system. That data isn't flowing yet. They've been too busy trying to get it online and ready for users. But we have similar file systems, and we'll be getting the read and write IOPS, bandwidths, IO sizes, metadata, CPU usage, and then job-specific usage. And I actually have an example of that kind of at the end. So that's what telemetry data is. Sometimes I like to think of it as the movie Contact, right? So, here's this alien computer system that we all have that's speaking its language, and what my group's trying to do is translate that into sysadmin language or into user support language. So I will use the word user a few times. Most of the time, I'm not talking about the scientist running on the system. I'm talking about the sysadmins or the managers, whoever wants to look at that data, which I don't know if this is similar for y'all, but most of the time the sysadmins don't necessarily want the users looking at the data. But yeah, okay. So why do we want operational data, right? So there's acceptance testing, being able to see how much power you're using during your HPL benchmark, right? Bronson had a really good graph of that yesterday. Being able to validate design decisions, being able to monitor all those components, building up your requirements for your next system, and then also just HPC research, right? Oak Ridge is a research lab, so having that data around so that people can use it for research is important. Okay, so our speeds and feeds, right? So we're monitoring Frontier and Summit and 7 other clusters. My group is in charge of the central hub where all the data goes, right? And making sure that that data is getting populated. So we also have file system data from 5 Lustre deployments and from 1 GPFS deployment. We also will take any other data that any admin or a user, an actual user, any data they want to throw at us, we try and be open and accepting of it, right, and pushing it through because we want to enable as much streaming as possible, right? So one of our customers, they want to take results, push them into a stream, and then have a different thing that reads the results and decides what to do next, right? So they're going to work on implementing that. And we're like, yes, you can absolutely push that through our stream. That's not difficult. That's exactly what we want you to do with it. So this is HPCM. So Frontier is HPE. So are the other 7 systems. What did I just say? 7 systems that we're using. So HPCM, this is their architecture. I don't ever have to touch any of this, which is nice. What I do is I connect into their Kafka bus, and we just clone all the data into our central system. And the idea behind that is that way all our sysadmins don't have to go to each HPCM system to get their data out. Instead, they can just talk to ours, and they can get each data from all the different systems at the same time if they want, however they want to. It provides a lot more flexibility. So, but HPE gave me this slide, the manager of HPCM. Yeah, they're doing a lot of work, and I don't have to think about it, which is nice. So this is getting the data off the nodes, right? I will say, and I kind of said this at Telemetry, but I didn't say it, we're getting a lot of powers and temperatures. We are not getting your OS level data. We aren't recording with every second how much memory each node's using. We have a different way that we're doing that on Summit, and users can opt into it, and that data does go to our system, but by default, we're very performance-minded. We don't want to give up any performance by collecting a whole bunch of extra metrics all the time. Okay, so our team, it's a small team. There are 5 of us, which is hilarious that I say that's a small team. At ConocoPhillips, we had 6 of us doing the whole cluster. We have 5 people doing analytics and monitoring. So our goal is to scale by centralizing the data streams, right? I kind of already said that. But we're working to standardize the infrastructure, the data governance, and the security so that we only need to think about one thing and everybody really only hooks into one place. We're not all disjointed looking everywhere. So our goal is to provide tools that add value and visibility to data. I already kind of said that too, but you just keep saying things the same different ways and eventually it'll click. So we want to empower leadership by backing their decisions with data, and we want to enable researchers to find new ways to improve HPC. Those are like the main goals of our group and what we're interested in. This is a high-level view of our platform. So all of these on the left are different streams of data coming in some way. We don't care how it's getting there, but they all go to Kafka. We call it Stream. It stands for something, but then they forgot what it stood for, so we just call it Stream now. But it's a Kafka bus, and we take all that data, and by default, well, maybe not by default, but the way we generally think of it is it's going to get consumed by Logstash and shoved into Elasticsearch. When I'm not being recorded, we can talk more about Elasticsearch, but not right now. That's how we think of it. It goes into Logstash, it goes into Elasticsearch, it stays there forever. Which isn't true, but that's just the way we think of it. And then people typically will get it back out with Grafana. That's how we do most of the things. But also, we want to enable people to do other interesting things, right? So we'll have customers or consumers who will tap into the Kafka stream themselves, and they'll duplicate it out, and they'll store things their own way because, that's the way they want to do it, and we're fine with that. The idea is we want people to have access to the data they need, but not have access to the data they don't need, right? So that's one thing that we have to kind of be mindful of. Okay, this is our Kafka hardware. I kind of love this slide, y'all. It's 6 nodes. That's our Kafka, those are our brokers. We're getting 25 megasecond through 6 nodes, and we're not even throttling or concerned about it at all. We just always add more, and Kafka's perfectly happy with it. So we have 128 gig of memory per node. Not even a lot. We're using SAS drives, and we do have kind of a lot of that. We have 223 terabytes of drive on these nodes. We have 160 threads, right? We need some compute for it. And then everything we do is containerized. So that's what this, weird, here's the actual node. We have a container that's doing Kafka, and we have a container that's the Elastic coordinator and master, because those can't be on the data nodes. It's kind of a detail, but it is there. So on these nodes that we have 160 threads on, we're still only provisioning Kafka with 16 cores. That's what that means, 16,000 millicores. That's, anybody do Kubernetes? Sorry, this was new in my role. It's weird, but it's nice too. So we have 16 cores that we're giving to Kafka, and we have this so over-provisioned because everything's through Kubernetes, we'll end up tossing other containers on here to do other things, right? So we could have had these scaled down, but we didn't need to. We actually, we're the tail of the dog, so we inherited this hardware, really. So that's the part that we need, and that's how Kafka runs, and it works really well. Here are some statistics on our Kafka, right? So this was, I think it was like 30 minutes whenever I took these pictures. This Grafana dashboard that we use to watch it. So these are our in megabytes per broker. I will say we just moved our Kafka onto new hardware, and in that process, we didn't actually have this dashboard for a while. I made it like a month ago, and once I made it, I noticed that the in data coming on one broker is a whole lot worse. Like, you kind of want this to look like a nice even pie chart, right, where everybody has a sixth. But one is weirdly hot, and actually in the messages, you can see it's really, really hot, and everybody else doesn't look like they're doing anything on the input. And it was like, huh, this is the whole reason my group exists, so that other people can find this stuff out about their data. It's nice that I get to find out about it on my stuff too. So that's kind of what it was, and this data is actually one stream that only has one partition, and so it's partitioned on that node, and it needs more partitions because then it would be spread out evenly across the nodes, which was cool to find, right? And it's interesting too to me though, that really, really hot node, we're more evenly distributed on output than we are on input. I don't know why. It's just, these are the interesting things you get to observe about data when you can actually see the data, right? If I were looking at numbers, I would never see these things. Okay, so then this is the dashboard that we give our users, and I kind of wanted to point out a couple things about it because it's how we're able to scale and just provide to any group that wants it. So up here, this is the max during this time frame. We hit 33 megasecond. This is our luster data. Every 5 minutes they send us data, so it peaks and troughs. The out data is 24 megasecond because we don't actually push everything into Logstash, right? Even though I think we do, we don't. In fact, that one really bad stream is what we turned off going into Logstash because we don't actually want to keep it forever. It's the log data of HPCM. And we decided we don't need to actually keep HPCM's logs for them because we don't ever want to look at them. So we have 140,000 messages going in every second. And then these are the groups. These mean nothing to y'all, and that's okay. But, you know, this is STF 002 HPC, that's our sysadmins. 023, that's our storage group, right? This is our infrastructure group. They're who provide the nodes that Kubernetes runs on. STF 020 is Norman Weathers' group. They do the data transfer nodes, if y'all know Norman. So this is how we track it, and everybody knows which groups they're in. Oh, STF 218, that is Woong Shin's group, who he wrote a paper. It was at not 21's SC about power and cooling. I'll show a diagram at the end of it. Anyway, so they can look at, hey, what piece of the Kafka pie am I using, right? And then we also allow them to filter it up here, and they can look just at their group, what of my stuff is taking the most, and then they can also say, well, okay, what if I just want to look at the Frontier system? And they can look just at Frontier and see, okay, which groups are creating a lot of data related to Frontier. Guess what? It's the sysadmins, but, you know. And then they can also say, well, okay, what if I want to look at the luster trace data or the system metrics for luster, right? They can actually pick that, and there's a third graph here that I didn't put on here because I didn't want the slide to be too noisy. And it'll show them, okay, your luster data is split, and most of it's coming from, you know, F2. And then he would notice, oh, wait, there's none on Orion? Oh, I forgot to turn that back on, right? So that's the stuff that we're trying to allow them to notice whenever they're looking at our graphs. So, and that's just about the data coming into Kafka. Okay, the other thing that we have is Elasticsearch. We have 13 nodes dedicated to Elasticsearch. 7 of them are the cold nodes, and 6 of them are the hot nodes. The hot nodes are using SSDs because they need to keep the data closer and hotter. The others are using SAS. Long story short, these still aren't in production, and we've owned them since I got there, which is really annoying. But it's because, y'all know, we had to get the users to migrate off of our old Kafka onto the new Kafka. And because their stuff was working, it wasn't until I told them, hey, at the end of the month, we're going to shut down the old Kafka, that's when everybody actually moved. Not everybody. Some people were good citizens, but you know. So that's our Elasticsearch hardware. Again, it's not a lot. And then this is our Elasticsearch dashboard. We currently have 1.15 petabytes of data in Elasticsearch, and that's full. That's actually one of the things I really don't like about Elasticsearch, right? It's not going to reduce the frequency of your data. I'll talk about this in a bit, but therefore, whenever we get full, we have to talk to the users of some of our streams and say, hey, do you actually need to keep your data around? And it's always the Lustre people that we have to talk to, right? Do you really need a string of every message that came out of Lustre for 3 years, right? And he's always like, no. He's always the person who says, no, just delete it. We need, like, if you can keep a year, that's awesome. So we always have to go back and delete data, and we're working on, well, one, we're working on getting more data so that, or more space so that we don't actually have to do that constantly. And then two, getting it to auto-delete for the stuff that we really don't care about. Because we are torn as a group. It's like, one, we don't want to delete data, y'all. It's valuable, right? Two, not all data is valuable. So we try and talk to the users about what they actually need. But then we don't want to have to delete things that could be useful. Okay, and the next piece is Frontier has a whole lot of data coming in, right? And all the hardware I showed you previously has been owned for a while. So Frontier has its own data store that is massive, right? These nodes have a terabyte of memory, 15 terabytes of SSDs that are for the OS, and then 46 terabytes that are for the system, and then 1.5 petabytes per node that's for storage, cold storage, right? And 128 threads, and we have 16 of these nodes. And they're still not in production yet because y'all know how getting things in production goes. But so everything for Frontier is flowing through our Kafka right now and going to our Elasticsearch. And then once HPE finishes with ITDB, that's what it's called, ITDB, then we'll push all that data into here and we'll stop recording it in our Elasticsearch. That's kind of what that is. And they are they're cloning from our Kafka, and then they're going to timescale DB because then we can keep it and reduce the frequency. They're also pushing strings into Elasticsearch. That's how we're doing it. Okay, I'm now to the point of use cases, which I think is the more fun part. Somebody asked me, hey, do we have CDU data for our cluster, for Frontier? And I was like, let me look. Y'all, finding data can be really, really annoying, right? Because I have 200 topics. Now, okay, those all aren't Frontier, but it's like, is it in this topic or that topic? So there's a bi-weekly meeting I have with the guy who gave me the HPCM slide so that we can actually get them to give us a good map of where in what topics of HPCM is the data we're looking for. So anyway, I finally found it. This is the differential pressure from the facilities side. So I took the supply and subtracted the return. So you can see that all the CDUs are very happily grouped, right? That looks good. And then I did, okay, well, what about on the cabinet specifically? And all of them are grouped except one, right? And that really freaked me out until I thought about it and realized, oh, it actually has less pressure lost. So that's a good thing, right? So, but I pointed it out to our sysadmin, and HPE looked into it, and they're like, yeah, we're watching that one. This one is also using less power than the other CDUs. I don't have any answers for why that is. But it was just an interesting point, and as soon as I graphed it, this was super obvious, right? And we hadn't been looking at that yet, so it gave us one more thing to watch. So things like that, right? There's an example. And then like the real driving use case for this was Wongshin's Summit Cooling Intelligence. So this is a very busy graph that I didn't make, so I can't go into too much detail on it. But what he has telemetry coming off of Summit and off of the cooling plant and off of weather forecasting. So a little bit of data. Summit's cooling is ambient temperature. So is Frontier, right? So if it's cool enough, we don't have to cool the water with anything. We just send it outside, and in the Tennessee Valley, often that's okay, right? but based on weather, we might need to be using we might actually need to be cooling the water that's going to go back in. So he checks the weather, and he's pushing all of this through a Kafka bus, and really the end result is a dashboard that the people in the human engineer can actually look at and turn down the cooling if it's going to be okay, right? So I don't want to talk about his research. He's doing something similar. Hopefully it'll be better for Frontier, and we're working on, we're pushing all of his data through that same bus. So these are the things that are available to researchers, right? And when he was like, hey, I want to look at this weird piece of the data of Frontier, it's like, oh yeah, we already are recording that, and we're storing it just in case you wanted to look at it. So that's kind of the point of our group. A couple of future things, I already mentioned it. I really, really, really want to be storing stuff in timescale. Maybe VictoriaDB, we haven't figured out what we're going to use. That way we can keep the data indefinitely at a reduced frequency so that we can say this was our usage, 3 years ago. Because right now, we can do that for the OLCF systems because we never delete that because that's the mandate. But for some of the smaller systems, we have been cleaning it up so that we can keep everything else that we need. The other one that I really want to do, and it's going to be this year, is job dashboarding, right? And this leans into something that I didn't even have the guts to write down. But, okay, when we run jobs, when somebody has an issue with a job, they want to know stuff about the nodes, right? So you want to be able to have, ideally, you'd have a dashboard that can show you all the stuff you actually want to know in one place. You can look at the graph and say, oh, look, that's what's different, right? And currently, we can't do that, and we all have tools that we've gone to nodes, and you can run your scripts, and you can find, oh, I'm watching top, and I'm seeing that this thing is out of whack, right? I'm watching that process and seeing that it's odd. Things like that. But what could we do if we had a job dashboard that showed you the file system at the same time as the node information? So that's one thing that I want to do. And then what I really want to do is take that and, okay, Gary Greider, he talked about how they have 4 applications, right? Some of our customers are running on the smaller, not on Frontier, but on the smaller stuff, they're really running like 4 applications. They are not the same. I'm not saying that we do anything nuclear. That's not what I said. We aren't doing anything nuclear. It's one of the things I like about working at Oak Ridge. Anyway, that's an aside. Can we train a model on these applications, right? Surely. There are like 4 of them, right? And, okay, then you say that to systems people, and they're like, well, what are you going to do with that model, right? And it's like, I don't want to do anything with that model except just have that on a, like, okay, let me go to the next slide. Here is the, beginnings of the job dashboard. So we've done this with Luster data. We have read and write frequencies, IOPS, opens and closes, read, write, IOPS, and then bandwidth, right? And so you can select which job you want to look at, and it'll show you all these, right? We haven't gotten to the point of, like, show me each OST that I'm on. I don't know if I could do that and not kill the system, right? Like, so there's a lot that I have to think about before we do it. But the idea being, especially with these 4 apps, right? Like, hey, if you selected this job and it had the name A and then some other number, right? A1, A2. Well, I know that you should be an A, so you should be around this line or this line, right? We could put this on the graph, right? This isn't, it's not rocket science, right? But I think it would be very useful for people when someone comes and they say they have an issue. It's like, oh, I pulled this up, and oh yeah, you're above this line. You're doing way more opens and closes than I expected, right? That's weird, right? Why is that? And it gives us one quicker place to go. So that's one thing that I want to be doing in the future. Thanks for listening, and I think we have some time for comments. Not much, but these are all of our emails. You can contact us. Y'all, I understand that you have a whole lot smaller teams than we do at Oak Ridge, and we're happy to talk to you about this stuff and help you do it. So reach out if you're interested.
Hey, Tim.
Yeah.
So, yeah, all the points you hit on are exactly what we struggle with when operating systems and maintaining them. What you were asking about on the data, what we do with it. So what I would like to be able to train the models on is what normal operations looks like, and then find the anomalies. So when something goes haywire, a node's going haywire, a switch, something on the system is impacting performance of the other users. That I don't have. I'd love to have like, okay, here's what everything looks like nominally, here's how the performance should be, and then, you know, use the machine learning to somehow find the outliers or find the anomalies. I don't know how to do that. But
I completely agree with you, and that's something that we also want to look at.
the other thing I was going to mention is we do collect the job data with something we developed called TechStats.
Yep.
It does a sampling type approach because, again, we don't want to be too heavyweight on the compute nodes. So we're sampling the data and collecting it over time. And then once the job ends, then we send that all back to a central server that collects all that data. But we question whether or not we want to expose that to the users or not. It does collect all the system messages that happened at the time. Yeah. It also collects I/O operations, InfiniBand traffic, flops, counters, or whatever counters we can kind of collect to see. Ideally, we were hoping to do what we called a report card to the user. Like, here's how many flops you got, or here's how well your job performed, and you got to see, or you weren't doing very good. You know, to encourage better usage, but. We should share some notes. Unfortunately, the person who was working on it went to Intel, actually. But we got some other folks who are picking up that work and probably should collaborate on some of this on getting that job statistics.
If they're picking up the work, we should talk soon. That way we can learn it at the same time, right?
Yeah. So, anyway.
That's a good.
Looks good though. All that data is great from the sysadmin point of view. So.
Thank you.
So you show one slide with a big green cluster health button.
Yeah.
Just curious, what kind of logic are you going to put into that, or is it going to be like the Amazon
that green
cloud health button?
That one's not my logic. That's literally Elasticsearch just saying I'm happy or I'm not happy.
Today or forever?
Like currently. That's the way, it's the last action.
Have you given any thought on how you're going to build that logic in? So little glitches here and there aren't going to like.
I don't know. I have not thought about that. Right. So that would be. Well, I mean, honestly, though, on these size clusters, would it ever be green?
Well, that's kind of the point. I mean, it needs to be meaningful, you know.
Yeah.
And
no, that's a good idea.
So people, I need to go look into this.
Yes.
Versus, oh, yeah, this is, a little slow for now, but it wasn't 5 minutes ago, and it won't be 10 minutes from now.
Yes. I think that also hits at what is not normal, right?
Yeah.
And I think if we can figure that out, then, we could kind of give them an idea of, here's things, here's where it's normal, here's where it's not, right? On HPCM, they actually, I don't know if this is just for Oak Ridge or if everyone who uses it gets it, but we have a map of the cluster, right? So then you can look at every rack. So I could see it, right? Hey, we're gonna give you the normals, and here's the rack that's out of whack, right? We could do something like that.
So is your team and your infrastructure need and everything considered in the procurements? I mean, I see that with Frontier, you got some hardware, but is it sometimes an afterthought, or you're scrambling because you're cramming more data from more systems into old infrastructure?
So it won't be an afterthought for OLCF 6. Like, we're talking about that now.
So then yes.
Yes. Any other questions?
We do expose some of the user job information to our users, and some of them can actually benefit from it.
I think you're right.
Yeah,
I think
not
though,
everyone.
do you want to expose it to everybody and have someone call you up and say, hey, I went above that line for a second, right? I don't want to.
Yeah, we only tell certain users.
Yeah.
So Tim, where do you live?
Oh, I live in Katy. Yeah.
So if there's people that want to ask you questions and collaborate.
Yes. Please reach out. We can do lunch still. I am not in Tennessee. So, yeah.
Well, Tim, thank you very, very much.
Yeah. Thank you.